Hello, my name is Seth Horn. I work in Dr. Descoupta's lab, and this project is over the fabrication and rejuvenation of open tubular ion chromatography columns. Now, before looking at the work being done on this poster, it's worth looking at what open tubular ion chromatography actually is. Traditional ion chromatography involves passing a liquid containing ions through a packed column bearing a charge opposite to the charge of the ions of interest. With open tubular ion chromatography, OTIC, there is no packing material, and the separation occurs at the walls of the tube. This requires that the tubes have a significantly smaller inner diameter than that of traditional ion chromatography columns, which makes OTIC a perfect candidate for field use and potentially extraterrestrial use. Now, if you cast your eyes to the bottom left-hand side of the poster, you'll see a couple examples of these columns. The outer diameter of both of these is about 350 micron, and that small hole, which is where the fluid actually flows, is about 25 to 30 micron. So that gives you a sense of how small these guys are. Now, the one on the left is high-density polyethylene, and the one on the right is polyether ether ketone, which we call PEEK. Now, the polyethylene is one candidate for tube material, but the columns made of polyethylene become poisoned and lose their separation ability with time. The PEEK columns are another candidate, and in this poster we explore a possible method of sulfonation, which is a key step in preparing PEEK columns for use. For the polyethylene columns, we tried washing the column with various solvents, acetone, toluene, and sodium carbonate and water, with the hopes that we would remove whatever is sticking to the latex nanoparticles that makes the column function. We also tried recoating the column with latex. The washings did not work at all, and in fact reduced the capacity of the column with subsequent washings, which told us that we were destroying the latex nanoparticle layer that's on the wall of the column. Recoating with the latex nanoparticles provided temporary relief, but you can see in the graphs in the middle of the poster here, you can see that the peaks collapse into the void volume within 24 hours of use, although we noted that the capacity was unaffected by the recoating. So that's good. For the PEEK columns, we first tried to sulfonate the surface with solutions of 5, 10, and 15% chloral sulfonic acid with a glacial acetic acid. Chloral sulfonic acid reacts with water, so it was important to keep the glacial acetic acid anhydrous. We tested successful sulfonation by coating the outside of the columns with various dyes, methylene blue and rhodamine, and you can see at the bottom of the second column the results of that. Now, obviously, on the screen you can hardly see a difference, but with the naked eye it was a little more apparent. With that done, we decided to sulfonate the inside of the column and see if we could get capacity. And preliminary testing did show that the column is being sulfonated. Now, if you look at the titration curve with that very, very tiny arrow pointing to that peak there, you can see that we do have some cation capacity with the sulfonation, although we want to try different concentrations of chlorosulfonic acid and different washing times to improve that. Now, further studies should look into experimenting with different washing solutions that do not disrupt the latex particles of the high-density polyethylene tubes, and then hopefully rejuvenate them for further use. For the PEEK columns, more research needs to be done to fine-tune the concentration and wash times of the chlorosulfonic acid so we can get the maximal sulfonation with minimal erosion, because PEEK turns out to be soluble in high concentrations of chlorosulfonic acid. So in closing, I would like to thank Dr. Descoupta for his guidance, Dr. Shalor for his many clever suggestions throughout the semester, and for Anas for her endless help in the lab. Everyone's been terrific, and I thank you guys very much for listening, and take care.